Welcome to everyone. Thanks for coming. This is our first data science meetup in Copenhagen. This is our first meetup actually in Copenhagen. So we're really excited to be here. Sorry, I have got something prepared. I'm Shanice. I am the data science and big data recruitment specialist at Darwin. Some of you I know, some of you I'm still to meet, so I look forward to doing that. We run these events under our event brand, which is called Rec Do Tech. Basically, bringing people together like yourselves to share experiences and ideas. After the talks, there will be food and drink at the back. And then some of you have filled out question cards for the prize draw. So you'll be in for a chance to win a Google Home, a Fitbit, or an Amazon Fire Stick for the TV. So make sure you stick around. Some of you have heard him already. Our first talker is George Bezerra. He is the Senior Data Science Manager from TripAdvisor. He's joining us from the US via Skype. Hi, George. Thanks for joining us.
Hello.
George is going to talk to us about natural language processing with deep learning, so enjoy.
Sounds great. Yeah. Thank you for the introduction. It is a pleasure for me to be here. I know that I will be speaking through a microphone, through a video. It's not quite the same. I can't see you guys. But hopefully I'll be able to pass a message and people will be interested and have questions and so on. So let me get started. I will share my screen. Share screen. Okay. As you know, I am a manager of data science manager at TripAdvisor. I manage a small group of 5 data scientists and 4 engineers, and we build all kinds of machine learning systems for the company. We focus on the branches of attractions, which is things to do, and also vacation rentals. So anything that is machine learning related within those branches is our responsibility. And today I will be talking about natural language processing with deep learning, and I'll focus on a particular problem that we call circumvention, which is a very, very challenging problem. And let's see what you guys think. To give an idea of what data science does at TripAdvisor, there are several areas where data science is involved. So these are some of the main areas. We have online marketing. So we built a wide variety of models for search engine marketing and display advertising. So models for bidding on search engine platforms, segmenting users into audiences and so on. So a lot of complex models go in there. We have fraud detection in content moderation. One example would be fake reviews. TripAdvisor spends a lot of effort trying to detect reviews that are fake. We have payment fraud. We have inappropriate content like messages and text that we have to filter. Another important area is revenue optimization, where we have ranking algorithms. So algorithms that rank items on a page. We have conversion funnel modeling. We have customer lifetime value. So all those models, some of which are very complex, we have to build. The classic area of recommender systems with places to travel, recommending places to travel, recommending products, both on emails, offline, and live sites. So we do online recommendations. And finally, we have the whole universe of product, where we do text classification, image classification, we do personalization, content optimization, and power and enable new features that product is interested in that uses machine learning. We have a product called Vacation Rentals. It's one of the products at TripAdvisor, along with hotels and attractions and so on. And I want to focus on this product because the problem that we are trying to solve is It comes from this product. And the product is a website where you can go online and you can book houses and apartments for you to, spend the weekend, spend a night, spend the month for your vacation, for your business trip, and so on. So that's basically all that is. People that have houses and apartments, they can post on our website, and people go there and they book. One of the things that you can do as a traveler is you can send a message. And a lot of people, before they book a place, they want to send a message to the owner, ask questions, and make sure that that's really the place they want to stay. So a typical example would be user who says, hi, I would like to stay at your place. It's perfect. Do you accept pets? And an owner could reply with something like, yeah, we'd love you to stay with us. Yes, we do accept pets. So it's a good answer from an owner. But some people, they reply by passing their contact information. So please contact me at this email address. And that is not allowed. We don't allow that in our platform because what happens is that if the person is trying to make the booking outside of the platform, it's not a safe transaction. TripAdvisor is not involved in the transaction. It's not safe for the traveler. And we also don't make any commission out of the booking. So the idea is that all the communication should happen through the platform. And if there is a booking, then contact information can be shared, but not before the booking. And others can write messages like this. Find me at some other website, a competitor website, or even their own website. I can make you a better deal. So that's what we call circumvention. So this attempt to pass contact information, and which is not allowed by the platform. But those examples are pretty straightforward. Things become quite more involved, and the examples are more subtle than that. So, for example, in this first example here, we have search for, and these are real examples, search for Paradise House on Google, you'll find our website. So it's subtle, right? So they're not passing the contact information. They are indicating that you can find their website and through there. But they're essentially trying to circumvent the platform, and that's something that we need to catch. It's fraud from our point of view. Or something like call me at 555-27. So in this case, they're spelling the numbers because they know that we have filters for catching phone numbers. So people get pretty clever about it. That's our third example where someone the @ and the dot from an email address, they are spelling that so that it's harder to detect with some filter. And that final one is the person is masking the words, right? So they are creating new words. They are putting spaces, putting dashes to encode the message somehow, and to make it more difficult. And that is very challenging because if you do come up with some kind of method to catch those things, people will adapt, and you always have to be ahead of them, right? So in a way, you have to come up with a way that is more sophisticated than the humans themselves. Very challenging. So how can we solve this problem, right? One obvious way to do that is using regular expressions, and we actually did this before we had data science. This was the system that was in place, and we had regular expressions for everything. So websites, emails, phone numbers, keywords, and so on. And in total, we had about 2,000 regular expressions, and that is a terribly painful process of building those regexes. It requires an engineer, it requires engineers, and they are constantly changing, evolving, getting more complex. It generates a lot of false positives. The more complex the regular expression becomes, the more false positive it generates. It also, if you have something like Google or Contact Me, which could be associated with circumvention, but they also could not. Those are all false positives, and they go to manual review every time one of those messages is flagged. And think about the amount of work that humans have to do on the other end of things. It's also not language specific. Sorry, it is language specific, which means if you want to adapt to other languages, in many cases, you just have to rewrite your regular expressions. So we can do better. And one of the things that you can do is to build a model. And one straightforward approach, let's call it the V1, is to use a bag of words classifier, right? Straightforward, standard natural language processing. We use the logistic regression with a bag of words, but we also added the regular expressions as features. So we created a combined set of features that has regular expressions in words, and we use that to train a classifier. And it actually works. It works really well. It reduces false positives by 2 to 4x. So it's a huge reduction in the manual work. But it's not perfect, and it's actually not good enough. It has several. This method has some limitations. One is that it relies heavily on regular expressions, and the regular expressions are easy to fool. And you'll see that in some of the examples that come later. And also, it cannot learn new patterns on its own. It requires new regular expressions because people are coming up with new ways of writing phone numbers, writing emails. Those regular expressions need to be updated. And again, this reliance on regular expressions is very costly. And then it misses character level features. The bag of words does not. It requires a dictionary of words. And if people are making up words, then it's not going to work, right? They can always bypass somehow by making up new words. And also, it's not great at capturing the context, capturing semantics. It doesn't look at the order of words, how close words are to each other, and so on. So it has limitations. Here we have some, again, real examples of cases where that approach fails. And so in that first example, we have the person put asterisk between the numbers, and our regular expression was expecting spaces and dashes, but not asterisks. Yeah, you can go there and update your regular expression, but you have to keep doing this forever, right? People keep changing. So pretty easy to fool. The second example is interesting. The person embedded the text, you can 91 reach me 49 on this 27 number. I hope you understand the message. So people get very clever because, numbers, you could be talking about numbers like the number of bedrooms and so on. And there's nothing wrong with that, but the context matters. And here it becomes difficult for the algorithm to catch. The third example is a false positive, actually. This is not circumvention, but it has, it says, please do not hesitate to contact me if you need information. So because the person is saying contact me, we do have a regular expression for contact me. The algorithm was trained and it thinks that overall it should be flagged as circumvention, but it isn't. Fourth example, you have a person who used Unicode characters for their @ and .com. So regular expressions, again, don't catch that. And finally, we have the last example there. The person used some Hindi characters, which I wasn't familiar with. But once we put this on the translator, we saw that it's actually a phone number. So yeah, it's pretty amazing. People are very, how do you say, they are very persistent, and they will try many things to try to pass the message. And it's not putting our it's putting our travelers at risk to deal with this kind of owner, I think. So what can we do, right? How can we solve those problems? How can we do better? And that's where deep learning comes in. I think one of the main hopes of deep learning, that's why we decided to go with this approach here, is that it learns the features at the character level, right? So instead of passing words, we're passing the actual characters to the algorithm. And by doing that, we allow the algorithm to build its own features. So we are no longer constraining it to a dictionary of words. The algorithm will learn what words mean and what things that differ from words are, and would detect those patterns. It has the notion of interpreting contextual meaning. You look at sequences and how things are close to each other, have recurrent layers, convolutional layers, and so on. It's language agnostic. As long as you have enough examples, you should be able to handle any language without any translation. And so we that's what we did. We built an algorithm. I'll talk a little bit about the model itself, of course, but the goal here is just we want to eliminate the need for regular expressions. That's a big deal for us. Even if we don't improve the performance, not having to handle regular expressions is a great improvement. Obviously, if we can improve the accuracy, improve precision, improve recall, and of course, by doing that, catch more circumvention. So the model that we came up with, it combines convolutional and recurrent neural networks or layers. We were inspired, of course, by literature work. And at the time, this was built, this is not our most recent model. At the time, there wasn't a lot of literature out there. I mean, but we came up with this architecture. It receives as input a sequence of characters. And this sequence of characters goes through an embedding layer that reduces the dimensionality. And then after that, you have a convolutional layer that has different future sizes. And then after that, you run through a recurrent layer. And that we use GRU, which were faster for us instead of LSTM. And then a dense layer that does your binary classification. We did experiment with a wide variety of architectures. We changed things a lot. We tried, and then we converged to this one. We even had architectures that had better results than this one, but they were too complex and they wouldn't work so well in production. They took too long to train and they weren't stable. So this is the model that worked well for us. For those that are interested in the more technical details, this was implemented in Keras, Python. We had 1 million labeled messages, and that's a lot of data. And the reason we had that is because of the previous systems. All those messages they were flagged for manual review. Over the years, we accumulated a lot of messages, and we were able to use those to train our model. We did 80-20 standard train test splits, trained this on a GPU, a Titan X, and the model takes about 3 to 4 hours to train. When you run the model on those messages that the previous algorithm has trouble with, we saw that we're getting actually pretty good results. So for all those cases, the algorithm actually solves the problem here. So here, the probability is the probability of circumvention. So you see that for the first case, you have close to 100% probability, which is correct. Here, 70%. Seems that it has a little bit more difficulty, but it's definitely above 50%. In the third case, we have false positive, so it's actually flagged that correctly as not being circumvention. And the last two cases, we have almost 100% chance. So the algorithm does a really, really good job at catching those very complex cases. And this was noticeable. The people who do the manual review and the people who work with the message, they gave us this feedback that it does seem a lot more clever than the previous strategy. How does it work when you deploy something like this, right? So what this figure shows is the distribution of messages, right? The number of messages as a function of the probability of circumvention given by the model. And what you see is that the large majority of the messages have a very small circumvention probability, and they're fine. And so those messages, they get forwarded automatically. They go through the algorithm and then they get forwarded. For a small fraction of messages, they have a high probability of circumvention. And so what we do, we block them automatically. So it doesn't even put through a human, it just blocks. And for a wide range of circumvention probabilities, we flag for manual review because the algorithm is not certain in that case. And of course, those thresholds, you can play around with them. But the idea is that the percentage that goes for manual review is actually a really, really small percentage. And when humans review those messages, that goes back to the training data, and then the algorithm gets better and better and better each time. So it's constantly improving. And we actually observe this if you look at the number of messages that gets flagged for circumvention and the accuracy and so on, it's just getting better over time. So yeah, we did have impact in our company, of course. And we did got the feedback from the reviewers that things are a lot better. But we found some interesting cases of impact in the community. In fact, we saw some online forums where owners they talk to each other about trying to circumvent the system. And so after we released this, we found some interesting comments. There are several posts but I extracted a few snippets. So in that first case, the person says, I thought I was about as sneaky could get, but even I can't get by the filter process at TA these days. So that's good. This means that they noticed the change. That second case, the person is saying, my replies always get stopped. I suspect they have something more than an AI system and that it is backed up by human screening. They're not wrong, actually. I just explained that. That's actually correct. And another person says, I would agree that spyware has become more sophisticated and phrases one could get away with in the past can no longer get through. So I thought it was a really good, validation of our methods. That's something that we haven't thought of. It's actually having an impact out there. So that's what I wanted to present. I think in terms of conclusions, deep learning works. I think it does have properties that go beyond standard natural language processing, standard machine learning. It's a very, very flexible tool, and it does have its place. It doesn't work everywhere, but it has its place, and it's now an important asset of a data scientist. At TripAdvisor, we use deep learning in several areas, fraud detection, natural language processing, computer vision, recommender systems. It just has so many applications. It really is an amazing tool. Deep learning is no longer black magic. Yeah, it's a keyword. It's a buzzword. There is a lot of hype. It's not going to solve all your problems, but it's very easy now. We are at a point where it's very easy to set up, to get it working. If you work with Keras, with PyTorch, even TensorFlow, I mean, the entry level, the bar to entry now is very low. It's become very easy. So there is no excuse now for companies and individuals not to be using those techniques. So with this, I mean, that's all that I had to present. I really would like to thank everyone, thank the opportunity, and I hope that was valuable information. I'm going to stop sharing in case people have any questions.
Okay. George, can you hear me?
I can hear you perfectly.
Perfect. Okay. We've got enough time for a couple of questions. Okay. We've got some time for a couple of questions. So just raise your hands if you have any questions. I'm going to go with this chap here first, and then I'll come to you at the back. Yeah, address it to George.
Yeah. Have you tried to use some other information instead of messages? I mean, some IP numbers, for example. If they're fraudulent owner, probably he or she can use it later, and so.
That's a great question. Yes, we thought about it, and we started investigating that. But in the end, we made a decision that really we wanted the algorithm to be good at detecting the messages themselves without any prior knowledge, because it does turn out that if the person has circumvented in the past, they are much more likely to circumvent again. But of course, there is a limit that we impose. If you catch them 3 times, they're out of the system. But I mean, we made a decision that we didn't want to have any bias. We want to give the owners the same chance. But I agree with you. We could probably increase accuracy by adding, where is the person writing from? I mean, where's the IP address, right? What's the location? What's the price of their property? How many properties do they have? All of those could be used. That would make the model a lot more complex, but I think it would definitely improve. I think one thing that we could do is to make an ensemble, right? So you take the output of the message model and combine into a single next model that has those inputs as features. I think that might be a really good way to go.
Great, thank you, George. Got one more question.
Hello, can you briefly talk about ethics of this whole thing? So I assume that the whole setup requires storing supposedly private messages for a long time, plain text, passing it to different people. Did you find it as an issue? If you did, how did you deal with that?
So can you, I mean, I'm not sure if I understand. I'll try to repeat the question. So the issue, you're asking if there is an issue with the setup, right? So like the infrastructure for this, like storing the messages, running the model in real time. Is that correct?
Well, it's not. So my question was about, so the setup requires storing messages between 2 people in clear text and sending them and sharing them with other people, with not really third parties, but with reviewers and such. How did you deal with it? Did you see it's like any ethical problems with that? If you did, how did you deal with that?
So I'm certain I'm not the legal expert. So take my point of view with a grain of salt. But I'm certain that to enter the platform, the person knows or should be aware that that information, is going to be screened by TripAdvisor. I don't think there is any question about that on the legal side. And the idea is that we are trying to improve the tool and improve the safety of the tool. So I think from a legal standpoint, there is absolutely no issue. But as I said, I'm not the expert. Those are not. That's different. I think it's considered different from personal emails like Gmail or so on. I think it's a little bit different.
Great. Thank you very much, George. I don't think we have any more time, so we're going to move on to the next talk. Obviously, George, I'm sure will be happy to connect. Maybe ask any questions.
Thank you so much. I appreciate. I will disconnect. I'll go mute here and stop sharing.
No, that's great. Thank you for your time, George. And we really appreciate it. Okay. That's it. Okay, so we've got 2 more speakers and we'll go to the next one. I'm going to introduce Shanice, who will give you the full introduction.
Our next speaker is Nicolas Horst. He is the head of Devoteam Discovery at Devoteam in Copenhagen. In between cycling across the Andes and leading a team of data science experts, Nicolas is going to talk to us about data science as a service. So welcome, Nicolas, and thank you.
What it is, okay, that's a lot of tools.
Yes. What it is that inside Devoteam, it's a management consulting firm, for those of you that don't know it. They bump into data all the time, and they can't really figure out how to deliver services on top of what they do normally. So 1.5 years ago, I came to Devoteam and started investigating what kind of services we could provide, and that meant when we ran proof of value with different companies to find out what kind of service are they actually looking for. And it ended up with Devoteam Discovery, which is data science as a service. So that's what I'm going to talk about. And if you're interested in cycling solo across the Andes, you can also talk with me about that afterwards. That's another thing. Good research. Okay. First of all, I'm not a data scientist. I have a master's in geodata and been working with geodata, but that's my background and how I came to work with data. Then I've been in the public sector, Ministry of Finance, working with something in Denmark we call the Basic Data Program. I've been with a big IT company, KMD, where I've been working with data strategies for them as well to leverage on data. Okay, this is what I'm going to talk to you about. Data science experts, the most wanted resource. What's the problem? Understanding data science. How Devoteam Discovery is supposed to help companies or the public sector. And then explain some examples and a little bit about the impact of data science, what we hear from our customers. Probably some of the things that you bump into in your daily life as well, but let's hit it. Okay, the most wanted resource. We've heard all the buzzwords. It's the most sexiest job of the century. But if you ask the CEOs out there, there's also a demand in big data and analytics, and this is translated into data scientists and data engineers in this context, because both of the expertises are really important to deliver data science as a service. Just a little bit short history. So for people that aren't familiar with data sciences, it's relatively new, and it comes from a lot of variety of fields. So as a good data scientist, you need to have coding and hacking skills. I cannot understate the hacking part, because that's where the data scientists that have to extract the data from the different data systems have to come to work. And then, of course, if you're more into the data science part, you need to have good mathematical and statistical skills, but you need to be able to code. And you have to be able to understand the problem within the business and be able to translate that. So it's from 2000 and forward where these data scientists have emerged from different kind of areas, and that's why they are really hard to get. Yeah. So what's the problem here? So data is the fuel for businesses, to operating businesses, but the journey is to becoming a data-driven business is challenging. So creating insights and harvest business value from data requires a specific and in-demand approach. So often it's refers to as data science, and the approach requires a new kind of experts such as data scientists, data engineers. Not all businesses are able to build these competence centers inside their company, and that's our different reasons for doing that. It's difficult to hire and attract these data scientists, and it's often it's because you can't give them the right space to work at. Often they will put into a normal delivery of IT, and they are getting bored because they don't work with data. If a data scientist doesn't work with data, it's not data science, so see you later. And this CEOs and business managers don't really understand. So it's difficult to create a business case. Yes, this is something you have to realize really early, that you don't build a business case. You start working explorative with finding solutions on your problem, and you're getting smarter along the way. So data scientists are a science, so you need to work in an academic way. So you don't need to deliver a blue on Monday, a green on Sunday, and etc. That doesn't work this way. Also, data doesn't have to be in silos. So if your data is in silos, your data science just doesn't deliver any value to you. So you have to understand that you need the competences, you need the IT to, so the platform to actually be able to work with the data science to gain that business value. So it's a difficult approach, but it's also a problem to gain the mass to actually get a good business impact on the business when you're starting. I'm pretty sure Wolf that come after me, which I just talked with, can tell you a little bit more about that. So you can probably not see all of this, but just to highlight a little bit, to talk about this story, we created this infographics. I will go closer so you can see some of the details about it. But we're starting over in the left side, and then this is where we came from without any data, and we come in and we get traditional BI. And where we are right now is that businesses are trying to go from the BI kind of way to steer their business to draw on data science. And there are some bottlenecks on the way. I'll go a little bit in detail with it. So if we start on the right side here, so with business intelligence, you see the problem over here. We have data in silos. And as the little guy is saying down here, we work only with historical data. So it's kind of trying to steer your car only looking in the rear mirror. So with data science, we can actually start looking out of the front window and steer our businesses with the data science products. So where we see businesses are starting and having problems here is to go from this state and actually go further. So what we've learned is that we start with some kind of proof of value here, where you find a core business problem, start trying to solve it, see how you can create value with not a too complex problem, and then from there you'll get the support from your managers to actually go over the bridge. And you can't see it here, but it starts with actually going to collect your data, so destroying your data silos, create your data lake. And on this infographic, a little bit of water. On this infographic, you can't really see the complexity in creating the data lake, but the data lake is kind of an issue from itself, because it's from starting out doing some small data products, working your way on and trying to get into a production environment. There's a lot of bottlenecks to go over, and that's where the data engineer actually come into place. So that's your foundation. If that doesn't work, your data science will probably not work as well, as good as you want to in the business. So you cross the bridge and you have a manager here that's actually taking time. That means that you go into a new maturity, so you can move from collecting data to describing data to discover data to predict, and then to actually do advice on data. That's the maturity level. If some of you are familiar with the field guide in data science, that's where you can find some of these expressions if you want to. So here we have the competences of the data scientist again. You move along the way, and from here you get the data lake started up. You're starting to make data pipelines, create data products. And to go into a little bit of detail, that's the step where which every data scientist has to work with. You acquire data, you prepare it, you analyze it, and then you create some kind of action on top of your data. And if you double click on analyze here, you have your goals, your data, and then the action you want to create as well. And the complexity of that goes into, you have to figure out what kind of data types do you have, what kind of analytic classes are we using, depending on how the complexity of the models, what kind of learning models and execution models are you required to have to create a data product. Your goal is to get this data product out in the end. So you have some constraints which will, you actually have to know these 5 factors to get a good data product. You move up, and then you actually in your factory, you have a production level, data science, which is in production, where you can actually put seeds, create data products which the managers will be happy about. It can be the products that predict or advise or discover. So you can set the path for the future and understand how you want to lead your business. So this was just a quick through our like infographics. So yeah, so 3 points which I want to highlight about what data science is here. Data science is for us the art of turning data into actions. It's the tradecraft that create data products. So you have a data product at the end, and it's pretty important here that the product is actionable information without exposing the decision maker, and it can be on all levels of the business for the underlying analytics. So that's kind of the thing. And one of the things, I didn't mention that on the drawing actually, that what data science does is it give the opportunity to shift between both deductive and inductive reasoning when you're working. It was some of the things that I set up here, but you can look at that later on. When you start gaining your data products, and the business owners is actually working with this, your managers, you're actually, I can see there's a little error here, but you have the basic for a cognitive automation. Means that when you do data products, you actually have an opportunity to automate some of your more manual process in your business. And this is for managers is actually a pretty important aspect, because they can be more efficient and be more productive at the same time. So it's important if you can't get your managers on board, tell them a little bit about this story. So how is it Devoteam Discovery is helping with data science as a service here? We have a ready-made service for our clients where we deliver a complete data science service, which consists of a team of experienced data scientists, which come from different areas, have more than 5 to 10 years of experience building Hadoop from the bottom, from open source into production environment, and data science as well. They work. This team that we acquired, we are really happy about it. We've delivered some of our proof of value with these guys, and they thought it so interesting to go into companies, see new problems, and create data science models or build the platforms which have to support them. Yeah, we also, it's Devoteam globally, we are a Google partner, so if we have to do a proof of value, we go with Google, and so our customers doesn't pay for IT, but pay for the proof of value with the data science. So here we have ready-made data sources on the platform from the Danish public sector, or Danish statistics, etc., which we can put in place if we need to use them for these proof of value. So, and of course, you know, there's libraries, methods, etc., which are pre-made. So, of course, we have these in hand to deliver it. So, our kind of value proposition to our customers, that we are experts in revealing the value of your data along the path here. So, yeah. What it is that we have is a ready-made and deployable data science department. So we can be your permanent data science function for your business, where we can be your long-term and scalable capability and capacity on the way. We can be expert service that solve a hoc business problem, adding capabilities to your team, or we can be a startup, or scale-up, I mean, data science function, adding capacity. And also as a startup service where we immediately can take advantage of our service. So instead of going on trying hiring, figuring out if there's a right data scientist, you can just bring us in and we can help you build your capability along the way. And if you want to, or get some capabilities yourself, you can have a subscription service where we come in and help you. It could be with hiring, or it could be a specific problem with the data lake and modifying some of the tools. Or it can, of course, be these proof of value of where I think, personally, that we will deliver in the beginning, because that's where we are in Denmark, is the start of the journey, except if you're in the C20 businesses. So a few examples of what we have been doing. This is a municipality, one of the bigger ones, which have an exchange server where they have all their incoming mail. Sometimes you get surprised what happens in the public sector, but that's a part of it. All mails come in, and they start, when they come in the morning, they start from the oldest, and then they go to the newest mail. Sometimes they have to look at if the mayor have some complaints, and they need to react within 48 hours, or they can be payments, etc. This is especially around payment, where they have to collect debt from citizens. So what we did here was, our challenge was to develop a prototype that could demonstrate that machine learning could accelerate their process time and requests from citizens. And so this was kind of the setup. We have the exchange server. We have solved cases from a system called eDoc from Fujitsu. And then we set up the rest around it and delivered different things, both for managers and also the categorizing in the mails, and our classification of these emails was 85 within the prototype, which was, for them, was a lot of value, because what the way we delivered the proof of value was to use Zebulon to show how we would change or make a plugin on their Outlook on where, so in the header, for example, we data mined all the relevant information under the header. So it could be CPR number, it could be a registration number on car, or etc. Because normally they would have these numbers, they would be within a file, within a file, within a file. So they had to click through a lot of attached documents to find these. Yeah, that's one. Another is for a major bank, and for somebody that is curious, I put in a French because we are a French-owned company as well. So it's not a French company, but a major bank where they wanted to see how they could validate information on cards and also enrich customer data. So this was done in TensorFlow. And we had a lot of success here. I'm not allowed to show what we extracted on the information, but it was above 90%. So a really good case as well. Another one is a food company, which, the challenge here was to extract information from consumption habits for consumers, so images, so it could be on tables or refrigerator, etc., and see if we could find the right products. And that we could. It was actually not that hard. So instead of doing these surveys, they could actually just send pictures, and then we could classify whatever it was, and this was the accuracy we could come up with after doing a project in a few months. Yes. So just to say a little bit about what will be announced tomorrow in the press, is that we're delivering this service where we can add in on the data science part. That's the key offer. But we can also do the platforms, since we have some really good guys that have been building these platforms. And then there is a team of people like myself, which have been working with data strategies, how to create a change management around it, because a lot of the part, if you want to press data science over your whole organization, is a change management concept that you have to build along the ways to change your culture and to change the way that you're running your business. So that's almost it. There is the impact. So I just took some numbers from some research, and it's from three different articles from MIT, Boston, and the last one I can't remember. So this is the impact if you're if you start out, and the funny thing is, the most companies, they start down here, because that's what we've been doing for the last 10-15 years. But it's actually these two ones which can really enhance your business over time. It's not easy. It takes time. which I guess Wolf will tell you a little bit about when Danske Bank is presenting. But that's kind of that's what we learned as a management consulting firm. So the department that I'm running, we're not doing management consulting. We're actually building stuff. So that's strange for a Devoteam. So we are the funny guys that sit in a corner and actually doing something. That's what we say. So yeah. And to finish off with, just to say this is not rocket science, it's something way better. It's data science because it affects our daily life on our phones, when we go to the doctor, when we go on a plane. So that's why it's cool, because it actually have an effect if the IT or the data science part is connected out to the business. Thank you very much. And then I guess Josh is saying it's time for questions.
It is, yeah, now it's time to get grilled. So let's, do your hands again. Question over here. Oh, yeah, question over here.
Try with the mic. Yes. Hey, I'm Wacek Kuśniaczek from Mask Digital. Working also with sort of big data science related stuff. One of the problems in data science, and especially data engineering, is scalability. Yeah. So you working with the cloud, and you can see a huge benefit there because you can scale your algorithms, your software. How do you scale your team?
That's actually it's a really good question, and I won't give you the formula, but say that we've been struggling with that as well, because of course we need a certain mass of competences to actually go out and deliver a service like this. So I'm not kidding if we talked with 500 people over the last half year, so 1 to 2 every day on 5 to 6 people, trying to figure out how to find the right competences, the ones that we actually think, because that's probably different approaches on it. So what we've done, we're starting out tomorrow officially, and then we have a pipeline, a really big pipeline on people that we are seeing. So we're seeing 15 people a week that are potential data scientists. So if we have clients or our business is growing, we can actually take in new guys. And that's a part where if we are delivering data science as one-off or selling a CV out to, it can be the tax office or it can be at one company, then it doesn't really make sense, because part of this is to it's a team sport. So you need to be a team of data scientists, data engineers, and the businesses that's solving the problems. So you need to be on-premise within the business to help them deliver it. And that's why we tell the businesses that we will help you find the right competences through our network and scale you up as well. And because we don't plan on being your data science department in the future, we are more interested in actually building the capability across businesses. So I don't know if that was a question to you answer.
Yeah, it's related.
Yeah.
I'm hiring myself, and I don't hire for data science position.
No, you could do it in data. Yeah.
Where we have a lot of need for data science, data engineering.
Yeah.
And we find it quite difficult and challenging. I mean, there are lots of applications, yes.
Yes.
Finding the right ones, making sure that you have growth in not just numbers, but also
Quality, yeah. That's my chief data engineer. That's his biggest concern. So he actually created a test where he is testing the capability of hacking coding and doing setup on, well, it can be changing. I can't remember the full test, but I think you're going in on NiFi and you have to change some of the source code in the open source to make a tweak on NiFi. So that's part of it. So it means that you're looking for some really,
It's more challenging than data science.
It is, which Wolf will probably also tell in a bit. Yeah, yeah. Any more questions?
Okay, we'll go to the one at the back and we'll come over to here.
Thanks. I'm a management consultant and data scientist from Tieto. My question relates to the cases you mentioned, best algorithms. Can you clarify? So which algorithm for which case?
There you go, that was a short one. And we'll have time for one more question.
Hi, I'm Dima Jakubowski from Copenhagen University. So my question is about what is the problem, what do you think is most valuable thing that your customer requested from you? So what is the most important feature of your products?
To launch an initiative like this, we've been out talking to a lot of managers and asking what they want, and what they tell us is that we need the full department. So if we're going to hire you in, it doesn't help us if you don't solve a part of the problem. You have to be able to deliver from back end to front end the whole way through. So if you want to do the other thing, then you have to compete against a CV house somewhere, and it doesn't make sense. So you have to take over the steering, the management, the model governance, the capability building. So that's what they told us. So.
Yeah, one more question.
Nicolas from Things in Flow. Doesn't that mean that they basically don't know what they need? I mean, we need it all. Isn't that what they're telling you? So, what's the real main pain point, you think?
This is the pain points, which we put in here. So you can see it here, but over here. So it's a missed innovation, it's missed opportunities, and it is market decline, or it can be a decline in their profit margin. So that's what they're looking at. They're being disrupted, or they're being competitive out of the market. So that's what the senior management is actually trying to do. So that's why the journey from just using business intelligence, and I'm saying you still have to use business intelligence because it's good, but you have to add data science on top of that or next to that to get the actionable insight to steer your business in the future. That's what they're looking for.
Would you say it's mainly defensive then?
No, that's progressive. Okay. They are looking to compete in a digital world where it doesn't matter if you're a production company, you see Google as your main competitor. So that's how they want to understand their customers. They want to understand their way to expand their business, create new business model on top of or next to the ones that they have right now. So they want to have a better strategic palette to choose from. Yeah.
Okay, thank you very much. No more questions, and that was Nicolas.
Thank you, Nicolas.
Thank you.
You're welcome. Our next speaker is Rittershofer. Did I say that correctly? Wolf actually got his PhD from the Oxford University at 2014, and he is going to talk to us about how we beat the rest, knowing your metrics, which is Danske Bank's excellent return from their data science team. So welcome, Wolf, and thank you.
Yeah, thanks very much for having me. I don't know, probably just need to get the PDF. No, where do you have my presentation, guys? Next slide. Good. Thank you. Like you think you're a data scientist and you don't even know how to. Cool. Thanks. So we talk about know your metrics. So we heard a lot about how to do data science, and now we're talking a bit how to actually bring it into production in a company that is very old and very traditional. So, but first a bit of introduction about myself. Yeah, I've been traveling a lot, and I finally ended up in Copenhagen after being in a lot of different countries. I'm a PhD in physics by profession, so I have a background in high-performance computing, data analysis, and pen and paper theory. Then I moved on to being already in England, just went to the city and become a quant consultant, where I was more or less a full stack risk modeling guy. So I was doing a lot of financial models, but also implemented them into production using into web app typically. So let's talk about Danske Bank. Danske Bank has the Center of Excellence approach. We have dedicated data science teams for around 2 years. And currently we have 2 different teams. One is customer analytics. This is where I work in, where we do everything around customers. And another team, our sister team, is dealing with risk. So they're doing a lot about risk. We have now further COEs starting up. So for instance, we have a pricing team that is currently 2 people. That's still halfway into our team, but might be as soon as I have a couple more people actually become more independent. And we're now at the place where we finally have our big data production system full up and running, so that's quite an exciting time for us. Me personally, I've been now 1 year in Copenhagen and also 1 year at Danske Bank. I think we're working in customer analytics. We talk a bit more, but it's mostly, as I said, everything about customers. And it's very exciting because we're a very young team, so there are a lot of opportunities. So I was the first one to put a Python model into production, which also means that I have to build up the production server for our Python. I was mentoring Indian colleagues. We have 10 Indian colleagues around. So I'm just a single point of contact for them whenever something's happening. And I'm also just, what is it called, product owner, in the product owner meeting, sitting around and seeing how we would like to build our Hadoop platform, which is now a job which is pretty much done for now. I hope at least. Let's see how that goes when we actually really start using it. Our team, which is custom analytics, so push turned into pull a year ago. It was pretty much around the time that I started that we stopped running around and trying to push very hard our data science onto business. After then, it is now we just reached the stage of maturity that business accepted that we're there and we're doing a good job. So they're now coming to us and asking us how we need help. Please help us with data science. We're now 20 people, 10 in Denmark, 10 in India, as I mentioned just earlier. Plus the technology that we have, we're a SaaS-driven business, SaaS enterprise miners, the whole bank. And this is not going away, but then we started using R and having a first R model into production. Then we went on to scikit-learn, so I have Python. And as I mentioned earlier, we're just now starting to use Hadoop. Whatever comes around it is mostly PySpark. We are now on the thing where we have 60 models in production. And the success rate that we have to get our models in production is 60% of those things where we successfully convince business to run a pilot on that. And 40% of our models are actually past the pilot stage, are out there just to actually create value. So that if you go to different meetups or you look in the internet, normally you hear numbers around 10 to 30%, depending which meetup you go. So we're quite proud about that. We're actually just beating the rest, and this is a beat the rest part that we talked earlier, that we're actually very good in just bringing our data science right to the clients and actually just creating value. And this is pretty much what we're going to talk about. How do we get there that we're actually having such a high success rate? So let's talk about the challenges working within the organizations, on the clients, on the business side. I think one, or if not the most important part, is the people factor. If you work with business in an old organization, those people are good in what they're doing, and they're good in what they're doing for a long time, and they take pride of their work. So you're the new guy on the block, and you cannot just go out and say, hey, we do data science, just move aside. And then people want buzzwords. There's a deep learning, AI, super cool chatbot stuff. They hear that, they read that, but they don't really. So they want to be part of the hype. But if it really comes down to delivering the results at the end of the day, you need to relate whatever you do in the terms that they understand. And the final thing is one way, it's all tied together, but it's like you need to create business ownership. You need to get the people involved. Those are normal people. If you just come to them with something they don't understand, they don't like it. They feel dumb. And nobody wants to feel dumb. They might even fear for their job. There's a whole lot of emotional things with them. And we'll just talk a bit more later how you can really relate whatever you're doing to business needs in the end. The second thing is what I call the Gigo versus pizza balance. So the first part, the GIGO part, is a garbage in, garbage out that is floating around, one of the buzzwords, which is you need to create a good data foundation. You need to create a good production platform to actually get going and do good data science. But if you come down to the pizza part, is bad data science is still pretty good data science. So, you know, you don't need all the good data foundation. There's so many low-hanging fruits around that it's just really, really easy just to go out there and just do data science very quickly, very simple. You can leverage your existing platforms. In our case, how I run Python models is I drilled a hole into our SAS platform. And basically, we just go out, do Python and R, and then go back in. So there's a lot of things you can do very quickly. And I think you hear that all the time with the agile stuff. It's like move fast, improve later. You can, with very simple models, showcase your potential. And then when it's really hitting off, you can basically go back and use your then now ready, in our case, a Hadoop platform to do everything a bit better. And I think the final part is, and this is where we're talking the rest of the day, is adapt your evaluation matrix to your business case. And this sounds very simple, but it's actually really, really hard. We had so many startups coming in, and they're trying to sell us a product. And it's actually, from a data science perspective, when I hear it, really good. But then if it comes down to it, you know, they just don't talk to those people who are actually hiring them, don't understand what they're saying. So they just basically get fired or out of the door. And so, yeah. So the first two you might have heard already in other meetups. There are things that are floating around one way or the other. I think this evaluation matrix and how that can help you with your business case is a story I haven't really heard, so I decided to talk about it today. So the example that we're talking about is a project that I've been working on, which is predict value reducing or churning customers. So I just use this as a synonym because churning is just a bit shorter as value reducing, not that you get confused. So we want to predict people who are going to churn or reduce their value by more than 50% in the coming months. So we can act on them, we can start calling them and asking them, you know, what's wrong, is there anything that we can do for you? So we want to run a machine learning model that helps us basically finding those customers who are going to churn and then just act on the 5% or 10% highest predictions. So if we now look at the business case, what is our business case? And it's just a very simple calculation, because if you start calling, you want to know the profit per call. And the profit per call is revenue minus cost of the call. Cost of the call at the bottom, here and here, is very fixed by labor laws. This just depends how much you need to pay the person who's actually doing the calls. And on the revenue part, you have the profit at risk per customer on the top. You just look in your historic data. The second one is the phone call success rate. This is how good is your outbound team. So given that you talk to a churner, how good are they in convincing the customer to stay with us? And then only the first part, and this is really the evaluation that comes into our business case, is the probability we talk to a churner. So how good is our model to actually predict who's going to churn in the next month? Or in other terms, how many phone calls do you need to actually reach a churner? And the profit per call is in that sense like an effective call. The more calls you need to reach a churner, the less profit you make out of each individual phone call. So the question is now, what defines a good model? And what metrics should we use? And then the question I pose here, the almighty rock. I mean, I don't know how many data scientists are here that actually know rock or area under curve as a metrics. Good, there's too few people. Good. So I need to talk about, because it's good because I have now a statistics detour. We forget for a few seconds about our business case and we go into our, I think this is the hardest part. So the receiver operating characteristic, or in short, ROC curve, is a simple metric which you don't see on the right. It is basically plotting the true positive rate versus the true negative rate. This is in very simple terms. Where you can see the more true positives you have, and comparing the true negatives, you have a curve. The more it goes in the right up corner, the better it is. And the closer it comes to diagonal indicates random selection. So this is just doing nothing. So the closer your model comes to doing nothing, the worse it is. If you're below the line, then you're actually worse than just doing nothing. This equates to a very nice metric, which is the area under curve, which is basically just looking at this area that is under the curve. And then you get a simple number and a simple school grade number which goes from 1 to 0, and everything below, you can read it for yourself. But it's hugely popular, I think, in data science and also statistics and farm industry if things work, because it's just a very simple number and a very nice grade that everybody who knows nothing about statistics can remember. So below all of that, and probably below most of classifications, where we say, is it happening or not, is the confusion matrix that I hope, again, probably the similar amount of people have seen, where it does plot your population, true positives, like where you compare reality and prediction. So the true positives are where reality and prediction correlate or are the same on the yes side. The true negatives are where reality and prediction are the same on the no side. So if we now look at our true positive rate and true negative rate, so we talked about the rock, it's basically this axis. So the true positives are a look where the reality is yes, and see, reality is yes on the top, and then we look at what prediction is it also yes. The better my model, the more I'm on the top. On the right side, the better on the right side, the better the model, the more on the bottom, meaning again reality and prediction agree. So now let's go slowly back to the business case. So the question that we're really posing is, how many turners are in my top 5% or in my target group? So what is the event rate in my target group? So the difference now between the rock and whatever my business case is that we go in a completely different axis, because we're now conditioning on the prediction is true. Basically what we want to know is, my model says this is a churner. What is the reality? Is this really a churner? And this is really the question that ties into our business case. And I think just before we go back now full-blown into the business case, just if you start working in data science, I think one of the very important things to know is there are very many metrics. And you can always go and see what is your evaluation, what is for you a good model, and this should kind of match the business case. And why it really, so you have a huge selection, there's many more than those two, but choose the right one that ties to your business case. And why? We talk about that now. So we're back now to business, and the question is now, what do we show to the analysts who have no idea of data science? So one of the slides, the first one that we're actually looking is data science goes in and saying, well, you could start calling randomly on those people, but you have a population, and like in that case, every fourth customer is unhappy. So we can now use a machine learning model, which is in that case nothing merely a fancy sorting algorithm, if you so will, where all your unhappy customers go to the left and all your happy customers go to the right. That's not perfect. That's like in school where you had to go sort by age, and there's always a bit of chaos in between. But the business case is basically, if you look at the top 5% all the way on the left, then actually there are 4 times more unhappy customers than there are if you just would randomly select them. So this is a typical number. You see the numbers and the plots are a bit lower. So the metrics or the plot that ties into that is what I call cumulative precision, where I say, well, you start acting on your top 20% typically, or top 10%, top X% of your people, and then what is the reality? How many turners do I get? Or really, if you're really tied to the business case, how many phone calls do I need to actually reach a churner if I want to just act on the top 20%? And this plot gives the answer. It's just around 0.4. So that's another way to look at it. Just if you want to know how much better than you are than just picking randomly, then you just normalize it by the base event rate, and you end up, this is 18 on the right side, same plot. You just end up around 2.1 times better than just picking randomly. And this is a metric called cumulative lift. It's just very nice when you can go to the people and saying you can pick randomly, but you are 4 times better if you just go with us. I think now we come to the point where we create ownership, where you really get business involved. Because you can give them some metric that ties in nothing. Business needs to come to you for any questions that they have. But really here now, if we look at the business case, you will see shortly that business has everything they need to do work on their own, to do their own decisions. And this is very important because they can do the job that they've always been doing. They can only always do better but we'll come to that like in a second again. So let's look at the business case in numbers, the one that we've seen before. So we know cost of call, business knows that because they know how much they're going to pay this person calling. Profit at risk per customer is just a historic number that you can get out of the database, and or businesses analysts, I mean they have a couple analysts, at least in our case, can do that. Phone call success rate is also a thing that basically it's a number you will find out during a pilot, but it's a number that business will give to you. So the only number that is missing for them just to do the whole business case scenario for themselves is the probability to talk to a churner. And now, basically, this is, as we've seen, exactly the plot that we've seen here before. Because now business can ask themselves the question is, how many people should we call? And you can say, well, yeah, calculate it yourself. You know exactly when the breakthrough is, where the break even is. You can have a high effective profit per call if you call very few people. You can start calling more and more people. Then you have a low effective profit per call, but the total volume of people that you're calling is actually much higher. So next thing is just a nice slide on the side. You can also just give them the realized potential and saying, well, you act on the 20%, top 20% of predictions, and you will end up reaching 40% of the people that's going to churn on statistics. So now business, because they can do the work that we've always been doing. So the only thing that we're taking away from business is they don't need to do business rules anymore to figure out who they're going to call. They don't need to use gut feeling anymore who they're going to call. Instead, they're using data science. So they can target their campaigns much better, much easier. And then, because they still get all the numbers, all the plots, all the things they need, at the end of the day, they're very much more willing to accept that they have no idea what's happening in the data science part. And I think this is not yet the conclusion, but pretty much the message I want to come across. So I have a couple more slides. This is typically the slide that I start with when I create the business case, where we go exactly in and saying, well, without the model, you need 10 to 50 phone calls to reach a customer. And with the model, every 2 to 6 phone calls we talk to a relevant customer. So the next thing is we have now talked to the analysts. We will now also have a slide for the managers. And very unsurprising, there's not a single bit of data science in there. Because the only thing the managers care about is the return of investment of the outbound call. So now I have a question. How much time do I have left? Because I either can stop here or I have a couple little anecdotes at the end for another 2-3 minutes.
I think you've got plenty of time to finish off and have some questions.
Cool. Wonderful. So a final little anecdote. So we talked about the metric. Well, let's talk about why my first few months at Danske Bank were pretty miserable. So the value retention project was based on an earlier project, which is done by an external consultant, which was our first R model and was just basically finished with the pilot just before I started. And the old model had a ROC curve or area under curve of 93%. And my model had a ROC curve of 79%, and I just didn't get it better. I tried everything. I asked them, did you do any fancy feature engineering? I was like, no, this is something weird. So like after a month of trying everything, trying to replicate every variable, I took their data set and just ran a gradient boost on myself, and I saw this ROC curve. And what's normally the thing is kinks are never good. You see up here, you've seen before a nice round little blob going around. Here's a straight line all the way to the right. And as I said, the more we go in the upper right corner, the better it is. So because this is really as much as the edge as it possibly is, this is perfect prediction. And it's perfect prediction of a significant amount of people. So what they were doing, I think you've seen that slide before, where we're saying, well, this is without the model 10 to 25 phone calls. With the model, it's 3 to 6 phone calls. But what I didn't talk about earlier, which was on the slide, but 50 to 80% of the people that we're trying to, 50 to 80% are not relevant for the modeling. So I excluded them. So the point is, these are people, for instance, value retention or value reduction on a savings account. Our customer base doesn't have a savings account. Or these are people with just 100 kronas on it. So you just lose 50% of the people or they're too old. So now the point is you could also do the same. You could include them in your whole population. And because they don't have a savings account, obviously they're 100% negative because they cannot churn, they cannot reduce value. I mean, without savings accounts, that's pretty hard. The point is, it is pretty hard to hide from your model the fact that they don't have a savings account. Because pretty much, a lot of variables depend on having a savings account if they exist or not. So what happened then is if you go to the confusion matrix as you think about again, so I all of a sudden have true negatives. 50 to 80% of my whole population is true negative in my model because my model knows those are 0. And the ROC curve depends on this very true negatives. So now what happens is you can now explain 50 to 80% are here totally perfect predictions of your non-churning customers, of your true negatives. So you can really, just by introducing the sort of threshold, you can pump your model, which normally would be a C, with like ROC curve of, what did I say, 73 or 79, which is basically a C grade model all the way to an A grade model and say, hi, I look really, really cool. So the thing is, if you look at the business case, we talked the business case, a number that really goes into the business case is the precision. So the precision doesn't depend on the true negatives. It's just the upper corner here. It doesn't care what's happening down there. So the business case doesn't change, and no matter how cool you look at the end, the money that you make at the end of the day doesn't change. The business case doesn't change, and this whole lift curve cumulative precision doesn't change. So this was a bit of a cheating, and when I found that, I was pretty happy. I mean, to be fair, I would rather be dumb and has learned some awesome tricks and just be wrong on that one, but it was they basically cheated a bit on that. But the key takeaway message from this little anecdote is you not only need to pick the right metrics, but you also need to know your metrics and the pitfalls. And we see that now here, so we finally made it to the conclusions, is if you want to do successful data science and bring things into production, you need to take into account the people factor. You need to put yourself into the shoes of the people who receive your model. What do they want? What do they need? You're the new guy on the block. They have their pride. They might be afraid to take away their job, as I mentioned earlier. So you need to go in. You need to demystify machine learning. You need to spend time with business, just sitting there. I did it a lot. Speak in terms that business understands, and especially deliver in terms that business expects. I mean, gives them the pride of, we're doing super cool, deep AI, whatever, but also at the end of the day, if they want a simple decision tree, it's just might be a boring project, but then it's a quick project that you do for them. And what really helps you communicating with business is choosing your metric wisely, tied closely to the business case, and basically pick the right one, because then all of the above is just all of a sudden very easy and falls into place. And the final from the anecdote, I think, know your metrics and their pitfalls. It's not only, as I said, picking the right one, because kinks are generally pretty bad. Kinks just means there's something funky happening in any metric, I think. And there's also no free lunch theory that you might have heard about. I mean, I had it several times along the way that all of a sudden I had a much better or much worse performance than I expected, or when I did something, and it was always an error. So it is really, you need to work for every % of model improvement, no matter what you do. So yeah, thanks for your attention. Thanks for coming and organizing. And a last word, I think we're hiring. I don't know if the job ad is out already, but I'll stick around, and there's my email address, so please, if there's interest.
Okay, guys. So we have any Q&A. We can start right away. First questions, please. Where is this? There we go. Right. So we're just going to close up with that. Let's open the floor. So hands up, please. Anyone with questions? Okay, 2 questions over there.
Okay, so in your formula for the profit per customer, you had this factor where you get the probability of persuading the customers to stay. Have you tried to predict that probability for each customer, or do you see any value in doing that?
No. I think, I don't know, is the mic, or am I loud enough for everybody?
Just want to make sure we get recorded.
Okay, good. No, we didn't do that. We haven't looked into that because I think the standard way, this is probably going in the direction of involved business. So we just ran a pilot, and we called, I think in Denmark, the original one we called around 4,000 customers. And now we are rolling that out in Finland, where I think we just finished calling around 1,000 customers. So now, theoretically, we had the training base to actually think about that, because we now have called enough customers to actually perhaps run a machine learning model on that.
Okay, got one more question. Who was it that had their hand up over here?
I'm curious on how you've created the feedback loop. So from like the perspective of the person making the phone call, how has their experience changed, and how did you design that that feedback loop?
So I think before we started the feedback loop, we did a lot of clustering and trying to give them as much information as possible to be calling. And then we record all the feedback. So basically the things that we record is a customer happy at the beginning of the phone call, saying, you know, basically, did we get the right one? And then we had a look afterwards, what did they talk about? And then afterwards we look, is the customer happy after the phone call? And then we just record that. That goes into the big database that comes out of that. At the moment we haven't really done any machine learning on the results. So it's mainly just oral talks. So it's just the outbound people talk among each other what works, what doesn't work. It is a bit, things that we learned are very basic things. You need to be very upfront if you do those phone calls that you're not selling anything. So that's the first thing that you learn, because you say, well, we're just checking out if everything's all right. The next lesson that we learned along the way is people don't open up. They say everything is fine, you know, it's super great, I'm super happy with Danske Bank, and then they just involve them in the chat, and then after 10 minutes, all of a sudden, yeah, by the way, you know, I have here just a contract of Nordea on the table, and actually I'm just about to leave the bank. So, you know, there are stories like that which but yeah, which are coming along. But it's not really like a full automated feedback loop, because mostly where we roll that out, again, I think we're now up to calling 6,000 customers, and it's just a small team that talks about what works and what doesn't work. Again, once we called more people and we rolled it out on a standard level that we call every month 200, 300, 400 people, then I think we need to go into automation, data science, and all of that type of things. I think one thing about it is just what data science really does. Generally, the people who do the outbound calls, they hate doing churn retention calls, because the people that they call normally that they're about to leave the bank are super angry, and they always went home in a very bad mood. With now we get the customers when they are still, you know, not super unhappy, but just before the call, we had several calls where they had the contract on the table ready to sign. We got them right at the right time. And the customers are super thankful that we call them. They're saying, well, I haven't heard of Danske Bank for so long. It is really great that you call me at this very moment. So my outbound team, they have so much positive energy. They're like, yeah, you know, another jackpot call. I just saved this customer today. So that's actually, it works. Do you have a? Oh, yeah.
I have a question instead for the metrics you presented, especially because you were talking how to present the metrics in a format that the management could understand. Do you have any maybe tips or like how not to cheat, or how the management maybe not to get, how to say, they will not get fooled so easy? Because you said, I'm going to present one slide with one number, and you presented a cheated version of a number, which was not technically wrong. It's just presenting a different side. Maybe they will get involved in external projects, and they will present these slides, and they will get fooled. How do you deal with that with Danske Bank management, for example?
I think generally people might have asked a question if they've seen actually the ROC curve, the actual plot. I think it was just a number. Or I think it wasn't even the ROC, but the Gini was presented, which is another metric, but doing pretty much the same. It's a good question. I think for me the thing is I now, for instance, also when I talk to our Bangalore colleagues, whenever they produce a model, they often also have like this little straight line on any of the sides. So what I say is, if somebody presents a metric for you, you need to understand the metric. You just need to go to Wikipedia or any other statistics stuff and actually read it up, and then you kind of know again which types of the confusion matrix it actually just goes in. And at the end of the day, if you tie the metrics to the business case, then you're pretty safe, because then you just, if your metrics changes, then your business case changes. Perhaps it is good because, perhaps you want to exclude 80% of your customers and you're happy just to have some sort of business rule. But, but I think generally there's no safety net. If you rely on a single number on anything you do, then you're fooled no matter what. So when I create my models just for debugging, I think I have 10 different metrics plots just in general. At the end, after I run my logistic regression or gradient boost or whatever I run in the given case, I just plot everything and I just look at everything and I see if something comes up that looks weird. And then, this king, for instance, it could be something good. In our case, it was a bit of a cheating, if you so will. In other cases, this might be exactly the business rule that you're looking for, and you just don't need data science to say, well, I found data science, found you these are the 3 variables you need to look at manually, and you're good to go.
Okay. All right, thank you very much. Do we have any more questions? Oh, we have one more question. I knew this one would be a bit longer, so we gave a bit more time.
Okay, I'm a little curious about, you did some kind of feature selection. And so which features are predicting churn for these kind of customers? Can you talk about that?
Did you get the question? Yeah.
I mean, I personally am a data scientist. There's also feature extraction, which are important. Are really boring work at the end. You need to go through an Excel sheet. But business wants them from us. But I think a few variables that came in, or I think the striking one that, I don't know if you've seen that very briefly. I had in the appendix. So I mean, it's not one model that we're running. We're running 6 models in total, looking at value retention across different product categories. And one of them that are very striking was always the meetings. There were people. If we haven't, what was it? Yeah. So if the customer hasn't been in a meeting or hasn't talked to us, and the longer they haven't talked to us, the more likely they are to churn. The more likely they are unhappy. So I think one general thing we found out from the business is we just need to do calls or get people in and just keep the communication, because people don't come in branches anymore. So we just need to do just regular checkups on customers and see if they're happy. The other one, which probably means that they're just moving the house loan, is if they had a lot of meetings just recently. So I have another variable that says meetings last month. So probably there are a lot of customers who are trying to buy a new product and then they were very unhappy with the offer that they got. So we also need to be better and just basically offering our customers the right product so that they're staying with us. I think there were many more. I mean, I think I ran in total on 300 variables. We have our analytics base table that we currently have has, I think, 900 variables on the customers. And I typically use, like, after decorrelating and looking at 2 to 250.
Okay, thank you. So that will close the Q&A. So thank you, Wolf. Yeah, and a round of applause. So that's it for today. Shanice, you're going to close off? Okay, I'll close. So thanks everyone for coming. Thank you for the speakers. It was a very successful live stream and a very successful meetup. We encourage you to stick around because we've got refreshments, as we promised, and there's some food as well that's due to arrive very soon. And also, if you remember at the beginning you filled out your forms, there will be a prize. If you got the question right, you've got a chance of Fitbit, Google Home, or Amazon Fire Stick. So there's plenty of reason to stick around, and we'll announce that. We'll announce that a bit later on. So yeah, thanks again, and I hope you enjoyed yourselves. And relax.